Hello, Mr. Hunley here, coming at you. Day 3, Science 9B, starting our unit here on space, the Big Bang, the solar system, things like that. We're going to start it off with one of the most important pictures maybe ever taken. This is called Earthrise. It was taken on December 24th, that's right, Christmas Eve of 1968. It was taken from the surface of the moon. They looked out their windows and saw the Earth was coming up over the horizon of the moon and not vice versa. We're very accustomed to the moon coming up over the horizon of Earth, but never the other way around. And this picture, I think, one of the cool things about it is it really shows that the Earth is sort of a thing, right? And it's hard to, when you're living here on the surface of the Earth, think of it as a thing. We always think of it as like this, unstoppable force. It's so big to fail, can't fail. And I think now more than ever, we realize that things that happen on the Earth affect the whole Earth. It's not an us versus them. It's not a, well, they're over there in Europe or they're over there in the southeast parts of Asia. It's things that happen there will affect us, whether it's pollution or the coronavirus. We are just people sitting on a object floating in the middle of nothingness, and if we don't respect that and respond to problems, there's nowhere else really to go. So this video sort of started the environmental movement of the pollution. Like, if we can't just pollute and assume that we'll just be fine, because we won't just be fine. And I think this is the first video that really showed that we are just something. We are just a ball floating in the middle of nowhere. So that is a really important picture, I think. And I'm going to start a video here. Well, I'm going to fake start a video. You're going to actually start it and move forward. But it's called the pale blue dot. It's an image that was taken by Voyager 1. The first image you see, there's a bunch of stars, and there's one blue one. And that blue one is us. That's Earth. It was taken on February 14th of 1990. You don't need to memorize these dates, by the way. I'm just telling you because I think it's interesting. But yes, Valentine's Day of 1990. It was taken by Voyager 1, which was a rocket that was launched in September of 1977, so a long time ago. And the rocket was just launched out into space, and it just takes pictures. And at one point on February 14th, 1990, it turned around and took a picture back of Earth. And that's all you could see. That's how far away it was. It was 3.7 billion, with a B, billion miles away. So you saw all these stars and all these things, and then there's just one little blue dot. And again, that shows you just how we are just one thing of many. We're nothing special. We're just where we are, and that just happens to be us. So at this point, I'm going to ask you to pause and watch the video. And then when you're done with the video, come back and we can talk about it. Thank you. Pausing now. Okay. Another video here. I know we're going to start with a couple of videos here, but before we get started too far along the line here, I want to show you guys just kind of what the scale we're dealing with here. We are a planet of a few planets in our solar system, and then there's one star in the middle. We call it the sun, but it's just a star like every other star. And as you'll see here, there's nothing special about our star. It's neither too big nor too small or anything like that. It's just a star. So this just sort of shows you that sort of the size of the things that we're talking about here. We think of the Earth as being monstrous, right? Huge, huge, big Earth, beyond comprehension. Well, you'll see if you watch this video that we are not the biggest thing out there, and not even by a long shot. So I will pause now, and you can watch this video. Pausing, pausing, pausing. Okay, now that we're done with that, those two videos, I hope you found them interesting and entertaining and somewhat informative. Obviously, there's not a lot of content in those per se, but I think they're interesting nonetheless. I find space interesting. I hope you find it somewhat interesting, and hopefully somewhat more interesting now after you've watched these two videos. But we are going to start off with the Big Bang. And our essential question here, you can take notes. Again, it's going to be really hard for me to grade them, but you can take them because that's what good students do, and we all want to be good students. So the essential question is, how did the universe really get started? Oh my gosh, look at this. Another video. Look at you guys. Video, video, video. This is what I do when I can't talk. I show videos. This is a video that basically goes over the beginning of the Big Bang. It sort of rewinds time and says, okay, this is how it starts and this is how it goes. And what I want you to do, take some notes on this. It's important stuff. We're going to go over it here in a couple slides, but I want you to just kind of look at the things and don't worry about the names of the epics and the eras and the this and the that. And there's lots of things, but really what I want you to look for is trends, right? Look at how long some of these things take. Like there's in the top left of the picture, there's a where it says how the time since the Big Bang occurred and the temperature of the environment at that time. It starts, I'll give you a hint, very, very quickly and very, very hot after the Big Bang, and then it slowly cools. Well, slowly cools down, kind of cools down. You can watch the video and find out for yourself. But again, don't worry like about this, that, and the other thing. Worry about the major ideas, the general ideas, and you'll be fine. I'm pausing now for you to watch this video. All right, moving on. This is an image. It just sort of shows you some of the ideas here. Obviously, it starts really, really small. I'm gesturing with my hand like you can see, even though you can't, and then expands out really quickly. And this is us. This is where we are. We're obviously on the right side. Again, the Big Bang was 13.7 billion years ago. That's a lot. It's a lot of years. So we're just a mere speck in the eyes of the universe. Here's some notes here. This is something I do if you haven't had me before, and actually first try, I really didn't do this a lot. I did this a lot more second try. What I'm looking for, there's a lot of words on some of these slides, and some of them are to help me speak and to talk and to remember what I want to say. The stuff that's colored is what I want you to make sure that if you're going to take notes on anything, the colored stuff is what I want. We use the term white, don't write. So if the text isn't white, don't worry about it. It's just basically for me. But yeah, the Big Bang, as you saw in the video, was both very, very quick in the instant. It really expanded very quickly. A lot of the first couple of steps were like in fractions of a second, right? And then it would take like millions and billions of years to kind of take those next couple steps. So it's both very quick and very long at the same time. And, you know, there was a nothing, just a super dense point of something. We don't even really know what. And then poof, it exploded and expanded out. And then everything that is in the universe now came out of that one small spot. Kind of interesting. Time, matter, energy, and space. So time was included too, which is really strange if you think about, we kind of think of time as a normal construct, but really time is just something that we made up. And so this whole idea that it came out of the Big Bang is interesting too. And I wish I had time to talk to you more about that. Get it? Time to talk. All right, so the one thing I want to stress is that of those first four forces that came out, the unified force, the first one that came out was gravity. And that's really important because gravity, as you know, pulls things together. Gravity pulls us to the earth. Gravity pulls everything to the earth because the earth is the biggest thing around. But really gravity, all it really is any two objects that have mass get pulled together. That's what gravity is. And so the earth, because it's so massive, pulls us down harder than everything else. But really, your computer is getting pulled towards you and you're getting pulled towards your computer at the same time. It's just such a small amount of mass. It doesn't do anything. You can't feel it, but it's always there. So we had all these things just floating around in the universe, right? And then gravity's like pulled two clumps together, and those two clumps got bigger and they got heavier, they got more massive, so they had more gravitational pull, so it would pull in more and more things. And so things got pulled, and that's how these big clouds of stuff got kind of pulled into disks of solar systems and suns and stars and all that stuff. And it all really stems from this idea of gravity pulling things together. But again, to get to that point, we had to wait a real long time. Things were so hot, nothing could really combine. Everything was just this massive balls of energy that weren't actually able to create mass because it was just too dang hot. But then finally, when things started to cool down, things started to form what we consider matter, and first helium, then hydrogen, and then that's basically the building blocks of all the stars. And then we'll talk more about stars in a little bit. But stars heat up, and then eventually they explode, and then they can control and create all these other elements that we know and use that you can see on the periodic table. But stars are still here. Obviously today we're in the star era, and stars get born, they die, explode, do lots of things, create black holes, but they're just moving through the life cycle. The sun itself is in its life cycle. It's 4 billion years old, and it's going to live another 4 billion years, so don't worry, we'll be long gone by the time it actually goes. But when it does, it'll be something you won't want to be on the earth for because it'll engulf us in flames. So, that's a happy thing to think about. That is the end of part one. We're just starting our journey here. We don't want to give you too much on the first day. We're going to continue on. There's 2 more days of the solar system, or of space as we know it. I hope you enjoyed this video. As you can see, I'm in my basement. It's very exciting down here. I really hope that you guys have a great day, and I will talk to you tomorrow.